Welcome to a short presentation on the root zone soil moisture approximation from ESA's CCI soil moisture dataset by means of soil water index. This work is being carried out within the Horizon 2020 funded G3P project, which stands for Global Gravity-Based Groundwater Product. So soil water index serves as simple means of approximating root zone soil moisture conditions as a function of time needed for infiltration. It exponentially weighs past surface soil moisture observations to quantify the conditions in the deeper layers of the soil. So an important parameter in the SWI calculation is the so-called t-value, which determines how fast the weights decrease and how strongly past surface soil moisture measurements influence SWI. Generally speaking, t-value increases with depth, although this relationship is influenced by factors such as soil characteristics and climate. So, for example, for a surface soil moisture observation taken 10 days ago, if the t-value is 10, it would receive a weight of 0.368. In the same scenario, if the t-value is 20, the same observation would receive a weight of 0.607. And if the t-value was 40, then the same observation would be assigned an even higher weight of 0.779. Now, as we can also see in the graphics, although most recent surface measurements are always the most influential, regardless of t-value, however, higher t-values also give substantial weights to older observations. Therefore, the smoothing also increases with t-value and depth. As satellite observations of soil moisture are limited to about the topmost 5 centimeters of the soil, soil water index is a useful approximation of the conditions in the deeper soil layers without the need for ancillary data and models. The appropriate t-value for the soil depth of interest can be selected based on correlation metrics and further calibrated for soil and climatic conditions. The concept of the G3P project is to resolve for variations in groundwater storage changes by subtracting individual water storage compartments from total water storage variations as derived from the GRACE and GRACE follow-on gravity data. As depicted in the graphic below, the water stored in glaciers, snow, lakes, and rivers, and as soil moisture are subtracted from the total water storage to arrive at changes in the groundwater storage itself. And the role of SWI in this project is to, as accurately as possible, account for all the water stored in the unsaturated zone of the soil and not just for the topmost 5 centimeters as observable from satellites. Hope this was informative. Should you like more information, please visit the project's website at www.g3p.eu. Thank you and have a great conference.